Everyone was a baby at some point. I know, it's embarrassing, but it's an important aspect of life and it affects evolution in a big way, especially for animals. In this video, I'm going to talk about baby animals from a planet called Origin. First, let's talk about babies that kind of just look like little versions of their grown-up counterparts. This is common for lots of non-archosaurian reptiles, like the Pseudosian stinkshell and the common anole. They're left to fend for themselves after hatching and are very vulnerable to be eaten by pretty much anything, including adults of their own species. While smaller ones like the anoles mature in less than a year, their larger stinkshells could take more than 5 years. For the latter, 30 to 100 eggs are hatched in a little nest by a river, and the centimeter-long hatchlings run into the water for relative safety. Usually less than 5 hatchlings make it to adulthood. The anoles aren't aquatic but go through a similar thing with lots of eggs and few survivors. Next is kind of the opposite of the last section. Let's talk about metamorphosis. In vertebrates, you can find this with many non-tetrapod fish and amphibians. Examples of that are the Anthropocean carp and the cow frog. The Anthropocean carp, like many other fish, hatches as a tiny larva with yolk still attached to it. It has no fins or scales at this point, so it kind of just floats around and can't eat. Once the yolk runs out, it's got fins and scales and can somewhat swim around. It filter feeds till it's big enough to do whatever fish do. The Anthropocean carp is a symbol of power and conquest in Anthroposia, because if you put it in an ecosystem, the carp pretty much just takes over. It's extremely hardy and can survive almost anywhere. As long as there's water, I guess. The cow frog has a more drastic metamorphosis. It hatches in the water as a herbivorous tadpole, and as it metamorphosizes, its stomach gets less complex to make room for other things like lungs, and it becomes carnivorous. Adult cow frogs tend to feed on insects. Similar to the fish, its metamorphosis is gradual as the tail shrinks and legs grow. In invertebrates, metamorphosis can be seen most notably in insects. There are 2 types of metamorphosis seen: holometabolism, also known as complete metamorphosis, and hemimetabolism, also known as incomplete metamorphosis. Examples are the scissor ofu and the violin screamer, respectively. Holometabolic insects go from a larva to a pupa to an adult, usually eating lots as a larva, and then the pupa stage being immobile, and then reproducing the adult stage. Some don't eat at all during their adult stage and die relatively quickly. The scissor ofu builds a nest inside other insects' nest for safety purposes, feeding the larva and the safety of the nest. Other larvae are on their own and feed on wild plants or decaying flesh, or a whole host of different things to eat. Hemimetabolic insects start off as little wingless versions of their adult form. The violin screamer and most screamers live a comparatively long nymph stage, feeding on tree sap. When they emerge as an adult, they only live a few weeks, making loud sounds with their wings every morning. Some have more or less similar lives as a nymph to their adult forms, but it depends on the species. I also feel the need to mention a non-animal from the planet. The name of the planet isn't important. What's important is that it's not Origin. A larval chrysomel, called an urnimal, hatches from a tiny 4 cm long egg and eats whatever it can whenever it can. They can grow up to 100 kilograms before they pupate and harden into a strange glassy cocoon. Chrysomels are sapient under every reasonable definition, but their development is extremely different from other sapient species, even those closely related to them like podogs. Their clutch can fend for themselves from birth, and in most cases aren't cared for by their parents. Their society is much more community-oriented in a way as a result. Anyway, the hatchlings are kept in the vicinity of the adults by constant food giveaways. The hatchlings don't seem to care much about anything other than food until they're about 12 years old and begin to be social. By this point they weigh more than 25 kilograms. By the time they're 18, they've usually pupated and become an adult chrysomel, but if they haven't, they might have similar problem-solving skills to a young human child. They also probably know how to talk at this point. They're capable of postponing their metamorphosis indefinitely, and there are communities of older urninals who refuse to metamorphose for socio-political reasons. I'll get into that in an anthropology video someday. Next is when the babies are differently proportioned to serve agility. This happens mostly with animals that are able to move around and at least somewhat fend for themselves right off the gate. Examples of that are the wildebeest and the hippogriff. Wildebeest calves are able to stand up and walk with their herd within minutes, and can run decently fast to the safety within the herd if necessary. Their longer limbs help them have longer strides and move faster for less work. They drink milk for a time, then live life similar to the adults. They have a higher mortality rate than adults due to their small size and vulnerability to plains and open woodland predators like the horsefly. Hippogriffs are similar for their longer legs that increase speed, but the hatchlings in the nest with eggs are left alone rather than cared for by adults. They feed on insects and progressively feed on larger prey as they grow. They must swallow their prey whole, which is why their head is so big. Another part of this is babies that have different colors than the adults. It usually has to do with camouflage to make them harder to find. Some examples are the Cyclops pig and the king dragon itself, the latter of which also has very different proportions, making it more agile than its adult form. The Cyclops pig lives a mostly solitary life in a wooded area, avoiding predators like the jaguar. After birth, they live with their mother for some time and have spots and stripes to avoid predators. This fades into the adult's color pattern within a few months. The king dragon has fluff that it loses in adulthood, which is probably for the best since it gets so big that fluff would make it overheat. It also changes its role in the ecosystem as it ages, going from a hunter of small prey to the apex predator we know as the king dragon. Lastly, I want to talk about babies that are helpless when they're born and reasons that might happen. The first might have to do with the biology of its parents. While Metatherian mammals, the only surviving families being the piner and the treeman of Senex, give live birth, they lack a placenta, and as a consequence their newborns are very small, sometimes less than a centimeter. They have adaptations to keep their tiny young in little pouches, so they're relatively safe. The pouches also have places for the tiny babies to suckle and get nutrients. This is nice for the mother as it reduces her chances of mortality with a pregnancy, but the baby just exchanges danger for different danger. Fun fact, a group of piners is called a pod. That's where the phrase pod of puny piners comes from, which is occasionally used to refer to a group of small children in Senex. There's also babies that are helpless for a different purpose, commonly found in carnivorans within eutherian mammals, but also some other active carnivores. Their babies are born small and underdeveloped, which means the parent never gets too overwhelmed with eating for 2 or 3 or 4 or whatever, while also having to hunt that food. When the babies can walk, the mother is then able to teach them how to hunt, while they're still getting a hang of being a scary predator. All that is true for both coyotes and jaguars, and a lot of other creatures. Lastly, for real, there's the babies of most sapient species that are quite helpless, and there are probably a few reasons for this, but the main one is brain size. Animals are the exception because their brains grow very slowly, but for example, sapient mammals have a limiter in how they give birth. If a head is too big, it won't be able to make it through the birth canal, unless it can somehow shrink. That's how you end up with baby pseudosians and humanoids having squishy heads till at least 6 years for pseudosians, and 2 for most humanoids. Newshoes are known for their tiny hatchlings that can fit in the palm of their or even a human's hand from their 6 cm long eggs. They have to lay eggs about once a month, so if they went through the danger that a pseudosian went through each time, not many would survive very long. So their brain growth takes place after hatching, and while they catch up to pseudosian and humanoid intelligence and size, after about 2 years, newshoe babies are significantly more helpless and require a lot of care. That's about it for this video. Check out my Patreon, which you can subscribe to for just $1 a month to support me and get your name at the end of my videos. Thanks Captain Kobop, Art of Dying, and Mr. Kale. If you're starting school, good luck with that, and if you're not, good luck with that too. Life isn't always easy, but it's full of rewards and opportunities. Thanks for watching.